Hey, so welcome back, and this is another daily code problem. So today it's called Decode Ways, and let's take a peek at it. So essentially, it's a dynamic programming problem that's like a medium level one, and all that you want to do is you're given a string here, and you want to translate it into like letters from A to Z. And what those numbers kind of map to is like a one-to-one relationship between like 1 and its corresponding like uppercase alphabetical number. And so really like it goes 1 to 26, where really it's the first letter of the alphabet all the way to the last letter of the alphabet, which is Z or Z. And so really what this would be is like 2, 3 would kind of map to B, and then the letter C, and so forth, okay? Just from left to right there. All right, and so what you can imagine here is that, say if you have the number 12 here, which I believe is, the first example, this can actually map to two different possible ways. One is you could kind of consider the split happening in the middle here, where it's kind of A and then the letter B here. Or you could just visualize it as just one number, so really just the number 12. And that would then map to, I believe, L, which is the 12th letter of the alphabet. Okay, and so that's great. So you'd return 2 in that case because you found two possible like combinations or permutations or whatever the right word is for it. And so if you have 26, well, that gives you 3 possible combinations. And so while I explain this one, I'll kind of map out what the recursive, what do I call it? Recursive nature, there's a word for it, but I'll show you the pattern, the recursive relationship that's happening here. That's the right word. So if we have 226, we can first consider either just 2 or we can consider 22, right? And then from 2, if we expand this, we could either consider as 2 space 2, or we could consider as 2 space 26. And then finally, from here, you can just consider 22, which we already have, and then just space 6. And then the last thing that we can expand is from here, which is 2, 2. And then we would add an additional space for 6. And that's how we get these 3 possible paths, which results in our answer here of 3. Okay, and so what you see here is at every point you can kind of go down at most 2 possible paths. And that's where, okay, you can either consider just adding 1 extra digit, or if you have 2 digits and that digit is within the range of 10 to 26, because really it has to be at least 10 if you have 2 digits, and the last letter of the alphabet is Z or Z, and that maps to 26 here. Okay, so if this doesn't make quite enough sense, we're going to do the that top-down memoization solution so that you can kind of better visualize it. And so let's go ahead and implement that. So what we're going to return is our dynamic programming function here, which we'll define just right here. And typically you start at 0 because you're going to go from the leftmost digit from left to right onwards to the final digit here. And so you just start at index 0. And the first thing that we're going to want to do is define our base case. In that scenario, we're just going to say, okay, if we reach the end of our string, then naturally we found, not sure, oh, I accidentally changed my keyboard. There we go. And so naturally we found a possible combination or path here. And so that's just, okay, if the length of our string is less than or equal to where we are currently, then we found a possible path. And so we kind of get a point if we reach this case, and we just return from there. And that way we kind of propagate that answer upwards. The other base case that we have to consider is, okay, otherwise if s at I is 0, then we're gonna just stop right there and return early the answer of 0. and that's just this scenario here where, okay, if we have a 0 in here, we can't map it to anything because you have to have at least 1. And so in that case, we just want to quickly, abruptly return 0. All right, so that finishes our base case. And now we kind of have those two possible paths that we can go down. And so what that is okay, one scenario is we just return the current step plus 1. All right, and that's just the path where, okay, let's just consider the next digit. But we also have that other case where we want to consider both one step, or we also want to be able to consider 2 steps from this point. All right, and so basically this is just going to be an if-else case. And so we know that we can consider both of these paths if we find that it's within the range of like at most 26. Otherwise, we don't want to consider like anything else from there. And so that all that is okay, if I is less than or equal to the length of s minus 1, because we don't want to go to out of bounds here. And so, and we just want to make sure that we're within that range of 26 at this point. And so because we're dealing with strings here, we're just going to have to convert it into an integer. And so in Python, you can just slice it. And so it's just from I to I plus 2. We're not doing I plus 1 because it's not inclusive in Python. So you just add an extra one here. Some people do like I plus 1, but we can just do that. And we just want to make sure that this is less than or equal to 26. All right, and so this will work, but the only thing, or it won't work, because the last thing that we have to do is just cache this. And so this just converts the function here into a, what do you call it, kind of a lookup table where the key is the parameters, and then the value that it's returning is whatever is being returning at that point in this function. So let's run this. Oh, looks like we have a problem here. And so what could that be? We want to make sure that this is that. And success. So sorry about that. We were just kind of considering too many cases here, and we don't want to go out of bounds there. So we just want to limit it to this particular scope. All right, and so let's go ahead and try submitting it. And success, so for time and space complexity, basically it is O of n time, but then also O of n space, because, well, we're caching here and it's a recursive function. But because of the caching and the added space we're using, it's allowing us to not get like a time limit exceeded in LeetCode or TLE, so that we're bounded to just O of n time complexity as well. You can actually do a bottom-up approach that enables you to do O of 1 space complexity, but for today I thought this was enough for me. But feel free to look at the solution to see how you can do a bottom-up approach that allows you to save on some space here. But this is pretty good, and you can also convert this. If we look at another one of my submissions, I believe this one here, you can convert it also to a bottom-up with the same space complexity of O of n very easily, where basically you just create a DP array instead of doing it recursively, and you just preset the first 2 possible paths to 1, because naturally there's only one possible way to start. And then you just move forward, always considering the step previous of it. And if you can, and you're within these bounds of 10 to 26, then let's also consider the possible permutations that you can get at the 2 steps behind it. Okay, bit of a different way of thinking about it. I won't go too far in depth explaining this. I'll just stop here. But if you want to stop and pause the video and take a look at this, feel free to do it. But yeah, I hope this helped a little bit, and good luck with the rest of your algorithms. Thanks for watching.